Biomedical data science is the process of learning from data.
Biomedical data science actually gives us the opportunity to do database management, where we can handle really large data sets, large amounts of data that's being generated constantly by cancer researchers, and also gives us very unique techniques for machine learning and in the newer generation of deep learning and artificial neural networks to analyze these large-scale problems.
So I'm a computer scientist.
I'm a computer programmer. I'm also a physician.
I'm a physician trained in pediatrics and later went on to do informatics.
I am a biomedical data scientist.
Focusing on cancer phenotypes and autism spectrum disorder too.
I'm interested in heart function and heart remodeling and how the heart's able to pump and how that changes if you have a heart attack or if you have high blood pressure or if you have valve disease.
My particular focus is microbiome research.
The amount of knowledge and data that's out there is doubling. And it used to double every 100 years and then every few decades, and now it's doubling like every year, right?
Biomedical information is accelerating at a very fast pace. And the data that's coming out of that and the information that's being generated is accelerating at an exponential rate.
What was large 10 years ago is no longer large.
So one trend in modern computer science and science in general seems to be kind of a convergence of disciplines.
So the opportunity for interdisciplinary collaboration is amazing here. So for example, for my research, I get patient data from Greenview Health System, which is the largest healthcare provider in South Carolina, and de-identify the data and feed it back to IBM Watson, because we also have an affiliation with IBM Watson as well.
Engineering, I think, is becoming less and less sort of single input, single output, and more how do we optimize this big system. And so that means not necessarily holding all of the knowledge in our head, but looking to data scientists, looking to bioinformaticians that can help us make algorithms, make workflows, make processes that allow us to identify these solutions within this complex space.
It is really one of the most exciting areas of medicine we've seen in the last 20 years. Completely changing the way that we look at things. All the largest companies in the United States are actively involved in biomedical data science.
Engineering companies such as Google, Amazon, Oracle.
So I think there's a huge job market out there.
One of the most exciting aspects of this new program is that it's a joint program with the Medical University of South Carolina in Charleston.
MUSC is doing a number of things to place ourselves at the forefront of this field.
Here at the Medical University of South Carolina, we have access to clinical researchers and clinicians, physicians, nurses that are top researchers in their field. So those collaborations that we can have here, utilize here, are extremely important.
We can leverage the clinical expertise from MUSC and the engineering and computer science expertise from Clemson and really build something special.
Data science is changing health.
Data science is the foundation of genomics, and my research centers on genomics work. And in that sense, it is very important in my area. And for biomedical informatics, I think it's going to transform healthcare. It's going to revolutionize how patients will be treated.
But the time is right now to get into this field because the infrastructure's in place, the data is there for us to get to.
If I was a student, I would want to be in data science right now. It is the field that all of healthcare science is converging upon. I don't think anything will be untouched by data science as we move forward.
I have probably 11 undergraduate students working with me next fall, and they're coming from a number of different fields.
The difficulty has not been fostering these collaborations, but being able to communicate effectively with each other and to be able to take the perspective of these different fields, right, of engineers and mathematicians and statisticians.
So I have one, he is a computer science major with a minor in biology. I have a bioinformatics major with a minor in computer science.
But when the student's there, that's the driver, that's really key. So the student has to be the person that responds to guidance from completely different fields, so they have to be a very creative person.
People who understand data science.
Achieving real breakthroughs.
To understand the biology, to use engineering approaches, to use computational approaches, statistical approaches.
To create new knowledge.
To find solutions which haven't existed before.